As promised, we are going to continue working on section 7.2 today. Our objective is to multiply binomials and polynomials. Anybody need more time with their objective? Okay. All right, our warm-ups are a little bit of a review from what we did yesterday. What did we do yesterday? We distributed. So we had to distribute this monomial outside into everything inside the parentheses. So 3x got multiplied by x squared. 3x got multiplied by negative 2x, and 3x got multiplied by 4. 3x times x squared. Ooh. 3x what? Cubed. Okay, sorry, I thought you said 2 instead of cubed. Okay, 3x cubed. Good. Remember to add your exponents when you multiply the same base. 3x times negative 2x. Negative 6x squared. And 3x times 4. So what sign do I need there? Plus, because it was a positive 12x. Can we combine any of those terms? No, all the exponents are different, so none of them are like terms. Also, it is already in standard form. Even if the directions didn't say it, it's nice for it to be in standard form. Good habit to have. Number 2 is a little different from what we did yesterday because we have to distribute how many times?
3. 4.
Kind of 4, right? With the 2x gets distributed twice, and the x. We have to distribute the 2x 2 times. We also have to distribute the positive x 2 times. So 2x is getting multiplied by both x and what else? Negative 3. The positive x is getting multiplied by what? And negative x. Okay, 2x times x is 2x squared. 2x times negative 3 is negative 6x. X times 5. So what symbol do we need? A positive 5x. And x times negative x? Negative x squared. Questions about what we just came up with? Okay, now on this one, can we combine any terms? Yes, we can. What can be combined? The x squareds. Good. X squareds combine with each other. Remember to keep the sign of the term that it's right next to. So 2x squared combined with a negative x squared is 1x squared. You could just put x squared. What about negative 6x plus 5x? Negative 1x. So you could write this as just x squared minus x without the 1's. That would be acceptable as well. I would take either one for your final answer. So what we're doing today, we will have to do some distributing like we did yesterday. But we are also going to have to be combining like terms. Do we have questions about our warm-ups before we do that? Okay. So you don't necessarily have these notes written on your page. We're just going to talk about them. I don't believe. Yeah, no, these are not on your page. You can still use the distributive property to multiply 2 polynomials together. It's useful to rearrange the terms of a polynomial so the degrees of the variable are in increasing or decreasing order. What that means is we want it to be basically in standard form. One thing I want you to make a note of is basically how this is going to happen. Okay. So multiply or distribute each term from the first, so each and every one, to every term of the second polynomial, combine like terms. This is also sometimes referred to as double distributing. If you have two binomials multiplied together, the old school way was to call it FOIL. First, outer, inner, last. We don't really teach it that way anymore, but if you have older siblings or your parents, somebody else that helps you with math refers to it as FOIL. That's kind of the old school way of talking about it. So I would write this down like in the margins off to the side somewhere, because this is how we're going to handle our problems today. Maybe Jaysha found a good spot on the bottom of the back side. There's a lot of blank space. Probably be able to fit it down at the bottom there. Leave some room for the problem, but jot this down somewhere in your notes. So here's our first example. We are going to distribute each term from the first polynomial. So that's going to be the x and the positive 4 to every term in the second set. So first I distribute x all the way to the back set. So I'm jumping over that plus 4. Okay, x is getting multiplied by x, and x is getting multiplied by a negative 1. When I multiply x times x, what do I get? X squared. X times negative 1 is negative 1x. That's like what we did yesterday. But today, we're then going to do it again. So now the 4 is getting distributed to every term in the second set. So we're going to have to take 4 times x and 4 times negative 1. What's 4 times x? 4x. Now, since we know we're going to have to combine like terms, where should I line the 4x up under? The negative 1x. So 4x here, 4 times negative 1, negative 4, which I'm putting on the end because there's nothing like it yet. You remember doing this when we had to add and subtract our polynomials on Monday, Tuesday, Wednesday? What could I put as my placeholders? Zeros. You don't have to do that. If you want to put a 0 in for placeholders, you can. You don't have to. So when we combine like terms, x squared plus 3x, make sure you're saying the sign that we're using. Minus 4 or negative 4. All right, on number 2. What's one thing that's getting distributed? Okay, y is getting distributed to y and to positive 2. What else is getting distributed? Good, negative 6 gets distributed to y and to 2. Now, when I write this out, that's not completely necessary. If it still helps you, that's fine to put it. What I'm about to write off to the side is what we have to have. What is y times y? Y squared, y to the second, y times 2 is plus 2y. Negative 6 times y, lined up under, good, negative 6y. Negative 6 times 2, I can get it, is negative 12, not lined up under anything because there's nothing like it. Okay, we're ready to combine our like terms. Y squared has nothing like it. What goes in the middle? A negative 4y and minus 12. And it is already in standard form. All right, let's do 3 together, and then I'll give you a few minutes to try the rest of the ones on this side. Or at least the next couple. We ready for the next one? Mm-hmm. Okay. I'm going to take 4 away while we talk about 3, just so I have plenty of space. On number 3, what is one thing that's getting distributed? 5y. 5y gets distributed to 2y and positive 3. What else is getting distributed?
4.
A positive 4. Make sure you keep the signs with it. So 4 gets distributed to 2y and to positive 3. What is 5y times 2y? 10y squared. Maybe I can't fit it all over here. 10y squared. 5y times 3. Plus or minus? Plus 15y. 4 times 2y.
8y.
Positive 8y. And 4 times 3. Positive 12.
Wait.
Are we getting used to lining up the like terms only?
Yeah.
All right, when we combine 10y squared plus 23y plus 12. Nothing else combines. We're in standard form. We've got our answer. All right, on number 4, what's the first thing that I'm distributing? 6t is getting distributed to
3t.
And
Negative
okay. What is 6t times 3t?
18t to the square.
Very good. And 6t times negative 5?
Negative 30. Wait.
Good. Negative 30t. Don't drop the t on that.
Yeah,
What else is getting distributed?
negative 1 to 30t and negative 5.
Good. Negative 1 times 3t?
Negative 3t.
Negative 3t. I'm going to line it up underneath my other t. What about negative 1 times negative 5?
Plus 5.
Say positive 5. When we go to combine like terms, there's nothing to combine with 18t squared. Negative 30t minus 3t.
Negative 33.
Negative 33t.
Yeah, t.
And on the end, we've got plus 5, nothing to combine to it. So there's our answer. Okay, this work or some version of it is what I would expect to see. Questions about example 4? If you didn't get it right, do you understand what went wrong? I hope so. We ready to move on? No one's saying no, so I'm going to go for it. Number 5, what's the first thing getting distributed?
3b, 2b, negative 3.
Somebody other than Deontay, tell me what I get when I do that.
6b.
Somebody other than Deontay. And somebody other than Deontay and Jasmine, tell me what else I need to distribute. Liam, was that you? What do I get when I do that, Liam? Very good. Lining up my like terms. When I combine, there's nothing to combine with 6b squared. You should end up with a positive 9b in the middle. And there was nothing to combine with the negative 27. Questions, concerns about number 5? Somebody that has not talked to me yet today, tell me how I start off number 6. Lydia? What do I get when I do that? Okay. Thank you for the assist. Somebody else that hasn't talked to me yet today, tell me what else I need to do.
-4 times y, and then -4 times 7.
Very good. What do I get when I do that?
-4 minus 28.
Minus 4y minus 28. We combine just our like terms. Everything else will stay the same. Questions about number 6? Concerns, confusion, need more time? Who got all 3 right all on their own? Good, good. Okay. Let's make it a little more interesting. This time, what's one thing that has to get distributed?
The S.
The S. What is
You
it
do
getting?
to all 3 of them?
All 3 of them. Very good. That's how this one's different. So S gets multiplied to every term back there. So what is S times 4S squared?
4s to the third.
4S cubed, or to the third. S times 5S. S times 5S.
5S to the second.
5S squared. Positive, so I'll put a plus. S times -3.
-3S.
Good. Now I have to distribute what?
The -2 to the 4 squared. 5S -3.
Very good. -2 gets distributed to everything. -2 times 4S squared.
-8. S squared.
Good. -2 times 5S. And -2 times -3 plus 6. Make sure you're putting signs so you don't get confused. This time we have a couple different like terms to combine. So 4S cubed. Then what? Minus 3S squared. Minus 13S. Plus 6. So really the process isn't any different. We just have a little more to do as far as terms go and then combining our terms. So I'll pause so that you can try the next couple problems. Again, this work that I'm showing is the work I expect to see, or some version of it. No, you don't have to draw the little arcs and arrows, but that does tend to help people remember what they're multiplying together. On number 8, what's one thing that gets distributed? 2y. So we're distributing that to everything in the second set of parentheses. 2y times y squared. 2y cubed. 2y times -y. -2y squared. 2y times 3 is positive 6y. What else needs to be distributed? A positive 1. Of course, multiplying things by positive 1 is going to make them stay the same. So plus 1y squared minus y plus 3. When we combine like terms, 2y cubed had nothing to combine with. Negative 2y squared plus y squared would be negative 1y squared. Positive 6y minus y. Or what? Dominic?
Plus 5y.
Plus 5y. Plus 3 on the end. Questions, concerns? Of course, if you needed to put ones in front of those y squared and y, that was just one of them, you could do that. Nothing to combine. It's in standard form. Questions on 8. All right. Number 9 gets just a little more interesting with multiple variables. Same process. 2x gets distributed. 2x times 3x squared. 6x cubed. 2x times negative 2xy. Very good. Make sure you're keeping track of the exponents on your variables. And 2x times y squared. 2xy squared. Now, I will tell you that when you start distributing the y, when you write your terms, I would put your variables in alphabetical order. Okay, meaning when we multiply y times 3x squared, I'm going to write it as 3x squared y, so that I'm still in alphabetical order. Or when I multiply, well, this one's already kind of in alphabetical order, y times negative 2xy is going to be negative 2xy squared. And y times y squared is y to the third power. Do you have questions about this before we combine our like terms? Okay. Nothing to combine with the x cubed term, so it stays the same. If we have negative 4x squared y plus 3x squared y, what do we get? Well, okay, negative 1x squared y. What happens to the xy squareds? They cancel out. Plus 2 minus 2 cancels out. And we would still have a plus y cubed. All of our like terms are combined. We don't really talk about or worry about a standard form when it comes to more than one variable. Jasmine.
Can I please use 2 different colors for the different variables?
On number 10, again, we've got multiple variables. Process stays the same. We're distributing xy to each term in the second set of parentheses. Xy times y squared. Xy cubed. Xy times negative 2xy. Okay, negative 2x squared y squared, xy times 3x squared. 3x cubed y. Questions before we move on to the next part? Okay. So now what are we distributing? 4, positive 4 gets distributed to everything. 4 times y squared is 4y squared. Is there anything there that we would want to line that up under? No. So we're going to just create its own little column back here. So a positive 4y squared. I actually might just move it up in line at this point. Positive 4y squared. Positive 4 times negative 2xy. Negative 8xy. Positive 4 times 3x squared is a positive 12x squared. Are any of these terms alike? Any of them at all? No, none of them are alike. Even though some of their variables match, the exponents on the variables don't match. So we would say that nothing can be combined, and this whole long thing is our answer. Again, since we have more than one variable, we're not really worrying about a standard form.
I didn't finish that, but I didn't know what you wanted us to do when that happened.
No, there's nothing to do.
So I saw that none of them lined up. I was like, well, I don't know.
There's nothing else to do. If they don't combine, then that whole thing is our answer. Questions, concerns? Okay, how is number 11 different from what we've done so far?
I guess they have to equal each other.
There's an equal sign in there. We haven't had any of these as an equation yet. This is our first time with that. So we need to multiply out both sides separately, and then we'll talk about what comes next. So on the left side, I've got to distribute my x to x and negative 5. X times x is x squared. X times negative 5. Whoa. Negative 5x. You're getting ahead of us. Okay, 2 now gets distributed. 2 times x. 2x. 2 times negative 5. Combine your like terms. X squared. Then negative 3x minus 10. And then we're just going to kind of press pause on that while we go over and do the other side. We distribute an x. X times x is x times negative 3. We also need to distribute the negative 1. Negative 1 times x. Negative 1 times negative 3. And then combine our like terms. X squared minus 4x plus 3. And we're just going to plop that equal sign right back in between them. If there's an equal sign, that means we need to solve for x or get x alone. What's nice about this problem is that if I say that I need to move my x squared, I would have to subtract it. But if I do it to one side of an equation, I better do it to the other side, which means that the x squareds do what on both sides? Cancel out, which leaves us with negative 3x minus 10 equals negative 4x plus 3. If I want all my x's to be on the left side, what do I need to do to move or get rid of this minus 4x? Careful.
Add 10.
Whoa. We're doing the x's right now.
Add 4x.
Add 4x. So we would have 1x minus 10 equals, what's still on the other side?
3.
3. Now what do I need to do?
Add 10.
Add 10, and we get that x equals 13. Okay, now you won't usually have to do that, of course, unless there's an equal sign in the original problem. We are going to finish talking about the rest of these examples on Monday before we review for your quiz.